a lot of the time, certainly in the high integrity when we talk about compliance, we're really dealing with standards. So we know standards are there's a very number of standard industry specific standards. So automotive has 26262. I mean, the high integrity has always had 61508. And medical and transport also have their standards. And the compliance, of course, is really trying to get you to work towards what we would tend to focus on, which is intrinsic quality. So intrinsic is the building blocks, it's what's inside the product, and typically from the outside you don't see it. Good compliance will enforce intrinsic quality. Unfortunately, many companies start to use compliance purely as a crutch or a tick box. So they think they're following a standard, and just because you're meeting that standard doesn't mean you've still got quality software in there. It means you can follow a process. So we have to be very careful of compliance. So our view is really building intrinsic quality, and is the education of the people writing the software and understanding these key characteristics of what do we mean by intrinsic quality. To get intrinsic quality, we have to review the software in many different ways. So we can think about code reviews, and most people, when they think about code reviews, is sitting around in a boardroom with slides up showing the code and people sort of commenting on it. That's really not an effective use. That's not a really good review. Good reviews really are about looking at design intent. So you're trying to get away from the detail, the minutiae, and saying, is it a good architecture? Things like coupling and cohesion. Have we got the right separation between the architectural levels? And worry less about the detailed low-level code aspects. For that, static analysis is probably the best tool in terms of return on investment. So what we're saying is we can take the code base in its static form, in its actual source form, and then apply tools to it to look for potential areas that could either lead to accidental, dangerous aspects associated with it. And the benefit of static analysis is it generally can be applied through automation. So when we look at the cost investment, it's typically not involving people, certainly at the analysis stage. Obviously the post-analysis is still going to be important. But we can't ignore the need for dynamic testing. Obviously there is a limit to all of these techniques. They can only do a certain amount. So dynamic testing plays another very important part, the ability to run a system. But of course that's more challenging with embedded systems, especially say if we've got to flash the board, we're down at firmware level, is actually being able to automate that testing is probably still one of the biggest challenges, and certainly one of the biggest challenges from the agile embedded community is, well, for firmware-based systems, how can we apply that dynamic stage? Even with all these techniques, they have, like I say, pros and cons. They'll have holes throughout them. There are certain things that will get through. You can expect that even in a review session, we're going to miss certain things. Dynamic testing can find certain things, but won't find others. And again, it all comes back to cost. So we're looking for the idea of return on investment, saying where is a good use of our tool? And certainly we're saying these are all complementary. So you wouldn't get rid of any of these at the detriment of others. But at certain stages, say for example static analysis, you could put together a number of tools there. So we're not saying there's just one tool. And the first one of those tools, in a sense, is the basic compiler warning. Now what we have to appreciate is that none of these techniques are perfect. So we still have to build systems in the context of failure. And here's a very simple example. Most people probably are familiar with this if you've been following things. So this was a good old Apple GoTo failure. That came along, and unfortunately it was in the SSL verification key exchange. And what is such an obvious bug, but when you're writing, and certainly when you're reviewing your own code and testing your own code, these sorts of things can be very easy to miss. So here we know we've got two GoTo statements next to each other. With basic C constructs, we know that only the first statement, the first GoTo, is bound to the if statement. And it's probably one of the most things that, certainly as an embedded program, you're looking at saying that code just wouldn't get through it. A traditional embedded compiler, your Kyles or your IARs, etc., or your Greenhills type compilers, they would flag that up as unreachable code, or all the code after that first GoTo, after that second GoTo becomes unreachable. What surprised me is when I saw this is that neither GCC or Clang by default threw out a warning of this. Because of course the code actually isn't illegal. It's nonsensical, but it's not illegal. And that's the problem with warnings. So warnings, obviously every compiler has to follow compiler errors and is working to these semantic and syntactical level of the standard, the ISO standard for the language we're working with. But warnings are very subjective, so that they vary hugely from compiler to compiler. And we can't rely on them. We know we have this tenet, we must always treat warnings as errors, but the reality is we cannot rely on them to do enough. Now things like Clang are getting better, they're improving that all the time, but today you mustn't just be relying on compiler warnings to give you good static analysis. So we've got to complement this with some further tool. The first mistake I see a lot of companies is when they start talking about coding rules is they're actually focusing on style. Here's probably one of the greatest battles people have in companies is where do we put the curly brackets, where does the block structure go? If you got the original K&R book, the Koenig and Ritchie book, then you'll see the style I think it is quite a common style, which is putting obviously the bracket after the if statement, we tend to refer to as the profit style. Where a number of other people would prefer to use the standalone. I certainly, because I came originally from an Ada background, then in the 80s, then moving into doing more mainstream C and C++, it's because of the begin and end structure, the same with the early languages like Pascal, I was more comfortable with the standalone method. But it really is a style thing. Now, style is important in terms of maintenance. We want to make sure code bases are readable, so style shouldn't be ignored. We have to have standard things like, from a company perspective, the copyright information in the headers, and we want information in, the comments in headers, for example, to give directives to people reading the code. But style will always be subjective, and there are tools that will help with style. If you want to enforce style, there are tools out there that will actually turn any particular code base into a layout. Simple things like tabs against spaces, again, where the curly brackets go. That is completely separate from a coding standard, shouldn't be part of a coding standard. So what we mean by coding rules, so here we're looking for things where we're trying to eliminate the opportunity to make mistakes that can yield to fault or failure in the program. And going back to the go to error, this is the simple example. So most good coding rules will have this directive that for any type of structure, so control structure like an if statement or a while statement, we must apply a block structure to it. So in the first example, that led to that go to fail example. Had that code, the people writing that code base, say for example, been applying MISRA as a coding standard, then that wouldn't have passed the MISRA rules. They would have had to use a block structure. Therefore, that error could never have got into the programming language. So the important thing about coding rules is we shouldn't be delving with style. Now, some rules do get on the boundary of style, and there are reasons to look at them. But on the whole, they should not be about style. They should be about eliminating the opportunities to make mistakes.